So I'm going to take up a couple questions with you from lesson 2 on probability. These questions are on page 247 of your textbook. We're going to look at number 6 and number 9. And in between number 6 and 9, I'm going to show you another example that might help. Okay, so we're drawing 2 cards here in this example from a 54 card deck. And it's 54 because there's 2 joker cards, one black and one red. Okay, so what's the probability that one of the jokers on the first draw and an ace on the second? Well, the probability of a joker on the first draw is 2 out of 54. The and part of this is very important. We now multiply the probability of an ace on the second draw, which gives us that right there. Now, for this first one, I will go through the math behind the fractions here. I would start by reducing these to 1/27th and 2 27ths. Okay, 27 times 27 should give you 729. So there's that 2. So you multiply fractions, you multiply numerators and denominators together, just in case you weren't sure about that. Okay, looking at number B. A red joker on the second draw and a numbered card of any suit on the first. Now, I would assume that ace is a numbered card, but apparently your textbook does not, which means that there are only, if I look at the first draw, there are 9, okay, so 2 through 10 of each suit. So we have 36 of the 54 cards are numbered. I would have thought that's 40, but the textbook's saying 36. Times the red joker, there's only 1 of those. Okay, and then if you multiply those together, you will get, I believe it's 1 out of 81, which is the correct answer. Okay, for part C. Queen on both draws for part C. So a queen on both draws, there are 4 queens. So 4 out of 54 times 4 out of 54 is your answer for that one. Okay. D, a black card on both draws. Exactly half the deck is black. So you can use 27 out of 54, which is a half, or you could just think about half the deck being black. That's got to happen twice, which gives you a quarter. Any numbered card less than 10 on the first draw, and a card with the same number on the second. So this is a little bit more challenging. Okay, so let's look at E together. A numbered card less than 10. So if we don't include ace as a numbered card, that means we're talking about 2 through 9. So there's 8 cards, 2, 3, 4, 5, 6, 7, 8, 9, 8 different cards, 4 different suits, so 32 cards. Your first draw has to be a card less than 10, and that's the probability of that happening. Now, what does the second card have to be? The second card has to be the same number as the first. So regardless of what number you got, there's only going to be 4 cards that keep you happy. When I say happy, I mean give you the right answer. So that will actually give you the right answer. So again, just to go through it, this is the probability that you get a numbered card less than 10 times the probability that that card appears in the second draw that you get. There's only 4 of them regardless of what one you get. So that's how that works. And then even a little bit more challenging is F. So let's take a look at F. Okay, so F is the red joker or red ace on either draw. Okay, well there are there's 1 red joker and there's 2 red aces. So the chance of getting one of those is 3 out of 54. Now this isn't an and, this is an or. Okay, so it's not like this has to happen both times. It only has to happen one of the draws. So we don't want to multiply. In fact, we should add, because our probability is going to be higher than 3 out of 54. So at first, to be honest with you, this is what I thought at first. This is very close to the correct answer, but it's actually not correct. And the reason is subtle and kind of hard to catch. Remember that this is the union rule for probability, okay? Event A or B happening, where event A is drawing one of these cards on the first draw, and event B is drawing one of these cards on the second draw. That assumes the events are mutually exclusive. They're not mutually exclusive. Technically, you could draw a red joker or ace on the first draw and a red joker or ace on the second draw. They can happen at the same time, these 2 events. So what I really need to do is take their probabilities, add them together, and then subtract the probability that both happen at the same time. Well, what's the probability that both happen at the same time? 3 out of 54 times 3 out of 54. They might both happen at the same time. That will actually give you the correct answer if you figure that out. I can't remember exactly what that is right now, but I'll leave that up to you to check. I think it's 35 out of 324 or something like that, which is just a little bit smaller than 1/9. The formula, by the way, that I'm using here is the probability of A plus the probability of B, subtract the probability of A and B happening at the same time. So remember, that was the probability of A or B. So the reason we need to do this is it's kind of hard to see, but in the incorrect solution, okay, you assumed, you double counted basically. You counted the probability of getting the desired card on the first draw and the second draw. You counted that twice when you do 1/9. So you actually end up needing to subtract the probability it happened both times. This is still including the probability of drawing, say, the red ace followed by the red joker. It's still including the probability where you draw both cards. You know, you draw a card on each draw. It's just subtracting it once because you actually double count it. Now I'm going to show you with a simpler example using a dice how we can kind of see how this works. And I'd also like to add that if you're having some difficulty with this question, don't panic. Probability is hard. We're just getting started. As we get going on this, it will be easier as we develop some more tools. But even still, let me show you just a bit of a simpler example. So suppose you're, say, playing Yahtzee, and you need to roll a 5. But you have 2 rolls to do it. What's the probability if you roll a single die twice? What's the probability you get a 5 on either roll? Well, you might say there's a probability of getting a 5 on the first roll, plus a probability of getting a 5 on the second roll. Okay, so 1 out of 6 plus 1 out of 6, which is 2 out of 12. Sorry, which is 2 out of 6, which reduces to a third. And when I play Yahtzee, and if I need a 5 and I have 2 rolls, I probably think my probability is about 1/3. And that's a good estimate. It's actually incorrect. Okay, why is it incorrect?
6.
Oh, sorry, I didn't know that I was going to say that. Why is it incorrect? Well, rolling a die twice is actually the same as just rolling them both at the same time. And remember this table. This table shows us all the outcomes. So imagine you rolled the die twice. What's the probability you get a 5 on either roll? Well, we could add them up. Could be, if we call this top roll 1, 1, 2, 3, 4, 5, 6. Remember, there's 36 outcomes here. Okay, a roll on die 1, 6 of them. And then die 2, look at this. There's 1, 2, 3, 4. I can't double count that one because I've already counted it. 6. So these are all the outcomes that correspond to getting a 5 on either die. Well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let me start again. I apologize. There are 6 plus 5, 11 outcomes where that happens. Not 12, because I can't count this one twice. So 11 out of 36, which is not quite a third. 12 out of 36 would be a third. So our original answer of 1, 6 plus 1, 6, it's like we double counted this. That's the exact same thing that's happening in that textbook question. You're double counting the fact that the outcome could happen, that the events are not mutually exclusive, and your outcome could happen at the same time, and you double count it. That was a terrible explanation, but I hope this is helping a little bit. So another way to do this too is to look at the probability of getting a 5 on either roll is like considering each roll to be event A and B, and we're calculating the probability of their union. Well, it's the probability of A plus the probability of B, subtract the probability of A and B. Well, it's this simple. A 6 plus a 6, subtract the probability of getting a 5 and a 5, which is that 1 out of 36 right there. That will also give you your 11 out of 36. So I hope that kind of helps. Okay, and the second homework question, I don't think it's as bad, but we have a paper bag, contains 3 types of candy, 10 chocolate bars. Oops, sorry about that. 10 chocolate bars, 7 fruit bars, and 3 packages of toffee. Okay, so we grab a candy, we put it back, and then we take a second candy. What's the probability to be able to keep a chocolate bar? Well, there's 20 candies. 10 of them are chocolate bars. So there's a 10 out of 20 chance that you get a chocolate bar on the first grab, and then the same as the second. Well, those are a half times a half, so you're going to get a quarter here. Okay, what's the probability to be able to keep any candy? Well, I would say the easiest way to do this is actually to break it down into cases. There's a 1 out of 4 chance that you draw a chocolate bar twice. We just figured that out. We could do the same thing for the fruit bars. There's a 7 out of 20 chance that you grab a fruit bar, and times 7 out of 20, that's the probability that you get 2 fruit bars, plus the probability you get 2 toffees. How many toffees were there again? 3. So that is the probability of a chocolate bar, plus the probability of a fruit bar, plus the probability that you get to keep a toffee. So we can add those 3 probabilities together. In this case, these 3 probabilities are mutually exclusive. You can't get 2 chocolate bars and somehow get 2 fruit bars. You can't get 2 fruit bars and somehow get 2 toffee. So none of those happen at the same time. So we can add all their probabilities together, and that will give you the correct answer. Once you get that answer, part C is just the complement. So you won't be able to keep any candy. That is 1 subtract your answer to part B. Okay, I hope that helps. Please send me an email if you have any more questions.